find VFC in the given circuit. This is the part of a previous problem circuit loop. So now in this case we know that the current is in this is I3 and this is I1, and the value of I1 and I3 has been calculated in the previous problem. Now we have to find the potential drop, that is Vf minus Vc, or potential difference between point F and C, that is Vf minus Vc. So in this moving along FEDC, because we have to find Vf minus Vc, so we will move along in this direction. Now in this from this here current is flowing in this direction, and current flowing is I1. So if we move from in this direction, so we find that this is at lower potential, this is at higher potential, this is our final point, and this is initial point. So final minus initial will be positive. So Vf plus 2I1, this will be potential across this is plus 2I1. Now again moving from this direction, again this is at higher and this is lower, so final minus initial will be positive, so plus 4I3. Now current is I3 and resistance is 4, so 4I3. And again moving in this direction, we go, this is at higher potential and this is lower potential, because it is positive plate and it is negative plate, so it will be higher, it will be lower. Now higher minus lower will be positive, so plus C plus 6 equals to potential of C, so Vc. So finally we get this imply Vf minus Vc equals to minus 2I1 minus 4I3 minus 6 equals to minus 2 into 1, because I1 has been calculated 1, minus 4 into minus 5/3 minus 6, putting the value of I1 and I3, minus 2 plus 20/3 minus 6, minus 8 plus 20/3, or minus 24 plus 24/3 equal to minus 4/3 volt. Negative sign indicates that Vf is less than Vc, that is it is in opposition to our assumed sense. Next question, find the current in branch of the circuit shown. Here is the circuit and we have to find the current in each branch. It is here shown the circuit. These values are given, that is this is of 21 volt. EMF is given 21 volt, 5 ohm, here 4 ohm, this is 5 volt EMF of this battery. Again this is 2 volt and 16 ohm, 1 ohm, 8 ohm. Now first to solve this problem, first show the current flowing in the circuit. So first for example we start that in this loop, for example in here I1 current is coming out, so and at this point it for example here it is going I1 current, so in this I1 current is flowing, and this loop I2 we have consumed as this in this I2 current is flowing. Here I2 current is flowing, so here in this direction, because I1 current is flowing in this direction, so I2 current is, so this in this circuit will be I1 plus I2 current is flowing. Again I1 will be divided into this direction, so I1 current goes in this direction, and this it is I2 plus I3 current is going, and in this I3 current is going, because at this point if there will be I2 plus I3, then at this point this will be go, I2 current will go in this direction and I3 current will be go in this direction. We can use Kirchhoff's loop current method. In this method we assign a current to every closed loop in a network, and KVL in a loop EAC. KVL in loop EAC, applying KVL, that is Kirchhoff voltage rule. So EAC, we are going in this direction. This will be 21 minus of lower minus higher, so minus of 5 I1 minus of 5 I1. Again in this I1 plus I2 current is flowing, so minus of 6 into I1 plus I2, 6 into I1 plus I2. Again in this I1, so 1 into minus of 1 into I1, 1 into I1 equal to 0. So 21 minus 5 I1 minus 6 I1 minus 6 I2 minus I1 equal to 0. This implies 21 minus 12 I1 minus 6 I2 equal to 0. This implies 12 I1 plus 6 I2 equal to 21. This is equation 1. Again applying KVL in loop CABC. KVL in loop CABC, we have to move like this in this loop. So we going in this direction. So it will be for this loop. In this circuit I1 plus I2 is flowing, and we are going from, it is at higher and this is at lower, so it will be positive. So 6 into I1 plus I2, this value will be 6 into I1 plus I2. Now again plus in this case, again we are going from higher, lower to higher. This is at higher and this is at low, so higher minus lower positive, so 4 into I2. So 4 into I2 plus 4 into I2, and in this case we are going at negative potential, that is lower minus higher, so negative minus 5 plus in this current is flowing in this direction, so it is lower and it is higher, the higher minus lower positive, so 8 into I2 plus I3, because current is I2 plus I3 in that circuit, so equal to 0. And solving we get 6 I1 plus 6 I2 plus 4 I2 minus 5 plus 8 I2 plus 8 I3 equal to 0. This implies 6 I1 plus 18 I2 plus 8 I3, 6 I1 plus 6, 4, 10 and 8, 18 I2 plus 8 I3. This will go in this direction, so 5 equal to equation 2. Again KVL in loop CBDC. CBDC, we are moving in this direction, so this will be, again here we see that we are going from in this direction, and it is at lower and it is at higher, so lower minus higher will be negative, minus 8 into I2 plus I3, minus 8 into I2 plus I3. Again in minus from this is at lower and this is at higher, so lower minus higher, negative 16 into I3 and plus 2. So we get here minus of 8 into I2 plus I3 minus 16 I3 plus 2 equal to 0 for KVL, and this minus 8 I2 minus 8 I3 minus 16 I3 plus 2 equal to 0, minus 8 I2 minus 24 I3 plus 2 equal to 0, 8 I2 plus 24 I3 equal to 2, or 4 I2 plus 12 I3 equals to 1. This is equation 3. Now from 3, I3 equals to 1 minus 4 I2 by 12, or 1 by 12 minus I2 by 3. Using this in equation 2, we get 6 I1 plus 8 I2 plus 8 by 12 minus 8 by 3 I2 equals to 5. Again equals to 72 I1 plus 12 into 18 I2 plus 8 minus 32 I2 by 12 equal to 5. This implies 72 I1 plus 18, 184 I2 plus 8 equal to 60, or 72 I1 plus 184 I2 equal to 60 minus 52. This implies 36 I1 plus 92 I2 equal to 26, 18 I1 plus 46 I2 equal to 13. This implies 18 I1 equal to 30 minus 46 I2. So hence I1 will be equal to 13 by 18 minus 46 by 18 I2. Putting this in 1, we get 12 into 13 by 18 minus 46 by 18 I2 plus 6 I2 equal to 21. and solving this, and finally we get 6 and 18 I2 minus 92 I2 equal to 63 minus 23. This imply minus 74 I2 equal to 37. This imply I2 equal to minus 37 by 74 equals to minus 1 by 2 ampere. Hence I1 will be 30 by 18 minus 46 by 18 to minus 1 by 2. Solving this, here I1 value 2 ampere. Putting this value we get 2 ampere, and I3 will be 1 by 12 minus I2 by 3 minus 1 by 12 minus 1 by 3 into minus 1 by 2, and 1 by 12 plus 1 by 6, 1 plus 2 by 12, 3 by 12 we can do 1 by 4 ampere. So this is the upper answer. So we have to solve like this. So using KVL and KCL we can solve complicated problem also. Next problem. Here a circuit or a circuit diagram is shown. Emitter A1 reaches 24 ampere. That is current is flowing in this diagram. It is a closed circuit. That is it is a part of closed circuit because current is shown. It is 24 ampere. What will the emitters A2 and A3 read? Neglect the resistance of emitter. In this only current flowing in this part is given, and we have to find the current in this and this, because A1 is connected in this circuit and A2 is connected in this circuit, and it is also of negligible resistance. Then we have to find, because which current is flowing in this line, that current will flow in this line. So for it, let's consider I is flowing in this. So I will be flowing from this also. Now after going through current at this point, divide into two parts, that is I1 and I2, and again it meets at this point and becomes I1 plus I2 equal to I. Now take potential at this point, potential between A and B, because these two are in parallel, so potential between A and B will be equal. So first we calculate from this direction and then for this circuit. So for it, VA minus VB equal to I1 into R, so 20 into I1, or 22.4 equal to 48 volt. Value of I1 is given. Again from this direction, VA minus VB will be equal to 30 into I2 volt. So from 1 end to 30, I2 equal to 48. Hence I2 will be equal to 48 by 30, 8 by 5 equal to 8 by 5 and 1.6 ampere. Now KCL at A, KCL at this point, that is I will be equal to I1 plus I2. So I equal to I1 plus I2, 2.4 plus 8 by 5 equal to 12.0 plus 8 by 5 equal to 20 by 5 equal to 4 ampere. So current in circuit is the value of I is 4 ampere. Next question. 3 resistance of the rheostat shown in figure is 30 ohm. Neglecting the meter resistance, find the minimum and maximum current through the ammeter as the rheostat is varied. Here it is shown. This is a rheostat, the variable resistance of 30 ohm. This value of this resistance is 30 ohm, and the circuit is shown. It is connected with a 5.5 volt battery or a cell, and this is of 10 ohm and this is of 20 ohm. Now this jockey, if this point will be at that, this needle will be at this point, then it is independent of resistance. There is no resistance is resistance facing for this will be 0, and when it is will be at this point Q, there will be a resistance of 30 ohm. So we can write directly. So when this point will be this needle will be at this point, the current will be maximum because this resistance is neglected in this case. Now we can calculate I max equal to Ey, and this is the figure for first case when resistance current is maximum. This is current is flowing like this or like this. So first we have to calculate its R equivalent. So I max will be E divided by R equivalent equals to 5.5 divided by, because it is in parallel, so 10 into 20 by 10 plus 20, 5.5 equal to 3 into 5.5 by 20, or 16.5 by 20 equals to 8.25 by 10 equal to 0.82 ampere. So maximum current in the ampere will show 0.82 ampere. Now for minimum current we have to set the needle at Q so that this resistance start to work. So it will be of 30 ohm resistance. Now R equivalent will be, we have to consider these three resistor. This will be in parallel, and again this is series with this resistor. So I mean will be E by R equivalent 5.5 by 10 into 20 by 10 plus 20 plus 30, because these two are in series. So solving 5.5, solving like this, we have 3 into 5.5 by 110, or equals to 1.5 by 10 equal to 0.15 ampere. So minimum current is 0.15 ampere and maximum current is 0.825 ampere in the given circuit. Find minimum and maximum resistance by the combination of three resistor 20 ohm, 50 ohm and 100 ohm. Now maximum will be R max RS equal to R1 plus R2 plus R3, 20 plus 170 ohm, and for R minimum RP, now 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3, or 1 by RP 1 by 20 plus 1 by 50 plus 1 by 100. Solving we get RP, hence RP value is 12.5 ohm. So this is the, when resistance are in series we get maximum resistance, and when it is are in parallel we get minimum resistance. Next question. Three bulbs. Next question. Three bulbs each having a resistance of 180 ohm are connected in parallel to an ideal battery of EMF 60 volt. Find current delivered by the battery when A, all the bulbs are switched on, B, two of the bulbs are switched on, C, only one bulb is switched on. The corresponding condition is shown by the figure. This is a 10 volt battery and these all are connected in parallel, and these are switch which is open. Now by the battery all the bulbs are switched on. When all the bulbs are switched on, that is, these all are connected, that is current is flowing from. Now because these are in parallel, so we can calculate R equivalent will be R by, because all are of same resistance, so equivalent resistance will be R by 3, 180 by 3 is equal to 60 ohm. So I will be E by R equivalent, 60 by 60 equal to 1 ampere. Second case, if one is second in two of bulbs are switched on, that is two are closed and one is open, switch is not, switch is off and two is on. So we have to consider only two, so equivalent of 2 will be calculated. So R equivalent will be R by 2 equal to 180 by 2 equal to 90 ohm. So I will be E by R equivalent, 60 by 90 equal to 6 by 9 equal to 2 by 3, 0.66 ampere, and only one is open. Then in this case only one R is working, so R equal to 180 ohm. So I equal to C by E by R equal to 60 by 1 by 3, 0.33 ampere. So from this example we see that when resistors are connected in parallel, then more current is flowing.